Hello everyone, welcome back to RE Adventures. In today's video, we will solve the third challenge from Flare-on CTF, which was named as Magic 8 Ball. In this challenge, we get a single package to download, which I have already done, and I have copied it into a directory. It was a 7-zip file, as you can see by the extension, and after extracting, it has all of these files except these two, the flag.png, which I have created, and the notes.py, uh, which is also created by me. But other than that, there are a lot of files here, and the most important one is SDL2. So if you are not aware of SDL or SDL2, uh, these are libraries, C or C++ libraries. I believe it has extensions for Python and other languages too, but essentially this is a library which is used for creating graphic stuffs and game. So if you have ever done game programming from the basic level, not by using game engines, but from like pure programming, then you might be aware of SDL. So if you would look at the size, these are rather big. Like for example, this is 500 KB almost. But the most interesting one was Magic 8 Ball. This file actually had a .exe extension at the end, but I removed it so that I don't accidentally run it. And it is only 21 KB almost. So we have to reverse this file. So let's just open it with IDA. And as we can see that it has symbols. A lot of the functions were automatically named and resolved. So we just jump to main, and in main it just calls another function, window setup. So it has a lot of code, this binary, but I was just looking around and then I found some interesting function here. Full SDL stuff. I was just looking around here and there and I found this stuff, this function. Most of this is just basic SDL stuff like loading images and creating window, creating the renderer. And then I found something interesting here. Some strings, some hex values, not strings. These hex values are stored at some offset from EDI. But if we would see, these are ASCII printable hex values. So if I would press R in this, it will convert, the IDA will convert this hex values into a string. And if I press R on all of them, we can see that it is storing some string at EDI plus 5, starting from EDI plus 5. And if I would copy this string into a notepad, and what it will be spelled out is, give me flag please, with a question mark at the end. So we have to note that this, because this will be used later on, and it is stored here, EDI plus 5C. Yeah. So this was one of the parts which was required for grabbing the flag. The other part was I was just again looking around, but I didn't find anything interesting. So what I did was I copied this into my VM and then I ran this binary. So after running this, we can see that this is some graphics program which says that press arrows to shake the ball, and we can also type some stuff here. If I press arrow keys, it will start shaking the ball, and I can type stuff at the bottom. So I was just looking for these strings like press arrow keys or start typing. So I did the same thing. I pressed in the IDA, I pressed Shift F12 to get all of the string, and I then searched start typing, and I found one string which was actually in the window. So I clicked on this and press X to get the cross references, and then I can see that it is referenced here. So this might be some interesting function that I thought, but it was actually just the same function that we just saw. So I was again stumbled. Then I was just again looking around trying to find some interesting stuff in the binary. And here we can see that there are in a loop a function is called. So if you have ever programmed a game, then there is essentially a game loop which is run infinitely, and there are functions that we call in this infinite loop. So I guess this was, I'm not fully sure, but I thought that this will be the game loop, and there are multiple functions called, but this one was the most interesting one. I even named this interesting function. And after we go inside this function, we can see that it is a really long function, as you can see it in this graph view. But after here, somewhere here, what we can see that there is an if ladder which compares byte by byte. It compares a byte from 4C, then again 4C, then 55, then 52, and you can also see that IDA has also converted this into a char like L, U, R, U. So we can assume that these are actually the moves that we just saw here. Like we have to shake the ball in left, up, right, or down. So this can be the moves which we need to perform in a sequence. Like if you would see at the first position, it should be a left. Then at +1, it should be again left. Then at +2, it should be up. So these are the set of moves that we need to perform. But what is interesting is after that, if you would scroll down, after all of these moves are done, then there's a string and compare with what? With ECX and then EDI +5. So does this ring a bell? We just saw it. We just wrote here that EDI +5 is actually this string that we just found out in another function. So now we know that we just need to perform all of the moves that were mentioned in the if ladder and provide the string give me flag please. Maybe it will give us the flag. So I tried exactly the same thing and I wrote the moves here. This is the moves and yeah, this is the actual flag you can see. So let me restart the program again and I'm going to perform the moves. And I have performed the moves. Now I just need to give the string give me flag please and the question mark, and it instantly provides us the flag that uh, it is the same flag as this one. You cracked this magic ball at flareon.com. So this was the dynamic approach. I actually tried to solve it statically, but I failed. Uh, for statically solving it, I was looking like how it is decrypting the flag. If we would go into this function, there are some strings encoded, and this somewhat looks like a RC4 initialization block. So I was just playing around with it, but this was way complicated than I thought. So I just stopped there and solved it dynamically. So that's all for the video. Thank you for watching.